Hello student, how are you? I'm Arun sir. Welcome to my channel Tuition Expert. Today in this class I will teach you the gravitation. This is the best NEET crash course series. Student, if you watch my video regularly and follow my class attentively, then I can assure you that you must crack the NEET exam confidently with a good rank. Now let's start about the class. Suppose every two mass of the universe attract each other with a force F equal to G m1 m2 by r square. All of you know the formula. Ap equal to always attractive force, and G is universal gravitation constant. Universal constant. Why it is called universal? Why it is called universal? Because the value of G does not depend on temperature, medium, that is density of the medium. So, and it is applicable for any two body of the universe. It may be very two minute particle, or it may be a planet and a mass, planet and a body. So this the value of G does not depend on temperature, medium, etc. So that's why it is called universal. So this force is always attractive force. That is, if one and two body are separated by distance r, then force attract on m2 and force attract on m1 will same, and this force is equal to F. Fixed variation of G means acceleration due to gravity. Variation of G with height. That is how G varies with height. Suppose this is a earth and whole mass of the earth is concentrated at the center. M is the mass of the earth. Now a body of mass m is at a height h. So what is the force acting on the mass? Force acting is denoted by Fh. So Fh is equal to, we know, m by, what is the distance? Where distance we consider from this to this distance is r plus h. So force at height h equal to this formula. The formula will be this, which is Fh. Now force equal to mass into acceleration. Force equal to mass into acceleration. Mm cancel, so Gh equal to Gm by r plus h whole square. Now at earth surface, that is at here, at earth surface, h equal to 0. So G equal to Gm by r square. So G equal to Gm by r square, that is Gm equal to Gr square. Now what is the value of Gm? Gr square by r plus h whole square. So formula of Gh equal to G into r by r plus h whole square. This is the first formula. That is how G varies with height. This is the formula. Gm by r square. This is also one formula. This is one formula. This is one formula. Now if from this we get Gh equal to G1 plus h by r whole square, which is minus 2, that is so this is another formula. If h is very very small to the r, h less than r, then we apply this formula. But generally it is not used. If condition is given that h less than r, then we can use this formula. Now variation of G with depth. Variation of G with depth. Suppose this is earth and a body is taken at a distance d. Body is taken at a distance d. So now the body is at here, and mass of the sphere m dash, suppose m dash is at here. What is the distance between these? This distance is, this is r, this is d, so radius is r minus d. Radius will be r minus d. Now force act between this mass and the sphere of mass m dash. So force equal to fd equal to g m dash by r minus d whole square, which is fd equal to mass into gd. Cancel, so gd equal to this. So gd equal to this. Now at the center, g equal to gm by r square. So if we divide gt by g, we get m dash by m and r square by r minus d whole square. Now what is the mass of the sphere m dash? What is the mass 4/3 pi r minus d whole cube, volume into density, but this density. Now rho is the density. We consider that rho is the density of the sphere is uniform throughout the density is same for all portion of the sphere, for all portion of the earth. Rho density of earth uniform. We consider rho is uniform. So here this, now if we cancel this, rho cancel, and r this cancel, this cancel, so cancel. So formula is r minus d by r, which is 1 minus d by r. So gd equal to g into 1 minus d by r. So this is the formula. Gd equal to g into 1 minus d by r, 1 minus d by r. So this is the formula. Now if we consider that this is the distance x, r minus d is x, that is if x is distance measured, distance of body measured from center, x is the distance measured from center, distance of the body measured from center, then r minus d equal to x. So this value will be g into x by r. The value of this will be gx by r. So this is the answer. Now x at the center, x equal to 0, so that's why gd equal to 0. So at center, acceleration due to gravity is 0, and so this is the formula, gx by r. Gt at depth, gt equal to gx by r. X is measured from the center, and if this is in terms of depth, then this formula is applicable. In terms of depth, this formula. In terms of x, if x is measured from center, this is the h equal to g r by r plus h whole square. So this is g r square by x square, because x is r plus h. X, what is, if we suppose this is earth, and we draw the variation of g with distance. Now the variation of g with distance. So when this is center of the earth, center, now the first formula is gx by r. So y equal to mx, this is y, this is m, and this is x. Y equal to mx. So graph will be, first graph is this is radius, variation will be this way. So next variation will be this. So first g is proportional to x, and then g is proportional to 1 by x square. So graph of variation of g versus x is this way, with angular velocity of earth, variation of g with angular velocity of earth. Suppose this is earth, and this earth rotates with angular velocity omega, and a body is present at the latitude lambda. Suppose this is the angular position of the body. This angular position is known as latitude. Lambda is latitude of body. Now this body rotates with angular velocity omega about this circle whose radius is r. Now, due to this angular velocity of the body, a centrifugal force act in this direction, m omega square r, and weight of the body act in this direction, which is mg, and a component of the, suppose this angle is lambda, and a component of this force along this direction is m omega square r cos lambda. So net weight, that is apparent weight, now will be apparent weight of body will be mg minus m omega square r cos lambda. So mg dash apparent weight, suppose mg dash g dash, if we take common mg, 1 minus omega square r cos lambda by g, cancel, so g dash will be, so g dash equal to g into 1 minus omega square. Now what is small r in this diagram? In this diagram, cos lambda equal to small r by capital R, so r equal to r cos lambda. So put r equal to r cos lambda, we get this. Now this value, this has a particular value because omega rg every term is constant, so this value is 1 minus cos square lambda by 289. Roughly value of this is 289. So from this is the result, g dash equal to this is the result. Variation of g with angular velocity of omega is this is the formula. From this we get this. So variation of g with angular velocity of earth is this. Now at equator lambda equal to 0, so the value becomes g at equator 1 g minus cos 0, so g minus omega square r. This is the value of equator, this is the value of g dash at equator. Now what is the value of g dash at pole? Value of g dash at pole lambda equal to 0, lambda equal to 90 degree, so g dash equal to g into cos 90 0, g dash equal to g. So no loss of weight when the body is at the pole. Weight is actual weight, no loss of weight. Now if the body is taken from pole to equator, what is the loss of weight? You can calculate. If a body is taken from pole to equator, loss of weight equal to omega square r, because g dash equal to at pole g dash equal to g, and at equator g dash equal to g into 1 minus g minus omega square r. So loss of weight equal to omega square r. Weight equal to m mass into this. So we take the weight of, if a body is taken from pole to equator, loss of weight equal to m omega square r. m omega square r, which is the centrifugal force at equator. M omega square r, centrifugal force of the equator. At earth surface become weightless. Now the formula is g dash equal to g into 1 minus omega square r by g. So if omega becomes, now value of omega square r by g equal to 1 by 289. Now suppose the value of omega becomes omega dash, so g dash equal to 0, 1 minus omega dash square r by g, 0 equal to 1 minus omega square r by g. So omega dash square equal to g by r. Now from this we get g by r equal to what? G by r equal to omega square into 289. So put here g by r equal to omega square into 289, that is 17 omega whole square. So omega dash equal to 17 omega. So what the result comes? Result comes is that if the angular velocity is 17 times of present of angular velocity, then the weight of any body on the earth will become zero. So the answer is 17 of omega. Now gravitational electric field. Next important terms is gravitational field. What is gravitational field? That is E. Gravitational field. Suppose a mass is present here at a distance r from this mass. What is the gravitational field at that point? Force by mass, defined as force by mass. That is if a mass m is present at here, now force equal to what? G m by r square divided by m cancel, so gm by r square. That is that is we can define that if unit mass is placed at that point, then the force acting on unit mass is called the gravitational field. It is directed towards this. Now the definition of gravitational field is due to point mass gm by r square, that is force acting on unit mass. This is the formula. Okay, now next what is the gravitational field due to different object? First uniform spherical cell. Suppose this is a spherical cell of mass m, radius r. Cell means this is inside is hollow. Cell means inside is hollow. Now what is the gravitational field at a distance r from the center? At here gravitational field equal to gm by r square. That is if the point is at here at a distance r, and here r is greater than r. What is r? R is radius of the sphere, radius of the cell. So if point is outside, E equal to this. If point is on the sphere, then E equal to gm by r square when r equal to r, and when the point is at here inside, then E equal to 0 when r equal less than r. So this is the gravitational field due to spherical cell. Graph of this figure will be E versus r. If you draw the graph becomes this way, because up to r gravitational field is 0 and outside the sphere, outside the cell, the graph will be like this. E is proportional to 1 by r square. Now for solid sphere, radius is r, mass is m, if point is outside, if point is at here at a distance r, gravitational field will be gm by r square, like the spherical shell, same as that of spherical shell. Now if that is here r greater than r, E equal to gm by r square, when r equal to r, that is if the point is at here. Now if the point is at here, E equal to formula will be minus gravitational field at this point. So if the point is at a distance r, now the mass is m dash of the sphere of radius small r. So here if we put m equal to 1 hat here, so gravitational field at this point will be g into m dashed into 1 by r square. Now what is, if rho is the density of the sphere, so rho equal to total mass m, mass by volume 4/3 pi rq, this is rho. Now so g equal m dash equal to 4/3 pi rq into density into 1 by r square. So r square, this cancel. Now this will be 4 pi g by 3 r into rho. What is the rho? Rho is this m by 4 pi 3 rq. So 4 pi cancel, 3 cancel. So this will be g m by rq, g m rq into small r. So result is this way. If you cannot remember the formula, then you can derive the gravitational field by this formula. That's just here you consider the mass of this sphere of radius r. Mass of the sphere of radius is m dashed. So mass equal to volume into density. Density equal to what? Density equal to, we have to write the gravitational field in terms of m. So density equal to mass by volume, put here rho, mass by volume. By simplification we get this result, gm by rq into small r. Now what is the graph of this? What is the graph of how gravitational field varies with r? What is the graph? Graph will be like this way. If we draw the graph of gravitational field for a uniform solid sphere, then the graph will be first like the gravitational acceleration due to gravity for a earth is scalar. Now what is the gravitational field at this point? Suppose this point is on the axis of the ring and at its distance r. So to find you have to remember the formula. How formula comes, just by shortly I show this. Now take this element, consider an element of mass dm. Now if so, due to this element, what is the gravitational field? Gravitational field in this direction, and due to this element, gravitational field in this direction. Now this angle is theta, so resolve this d we get this way. This is theta, d cos theta, d sin theta. Now d cos theta, resolve this, d sin theta, cancel, this cancel. So d cos theta integration, gravitational field will be d cos theta, integration of d cos theta. Now what is d? D equal to the gravitational field due to this mass dm. Now what is the distance here? This distance will be this, so d equal to g dm into 1 by r square. This now cos theta, what is the value of cos theta? Cos theta equal to base by hypotenuse, that is small r by this, small r, this. Now all are constant, only variable is dm, so integration of dm, that is if you integrate this, if we integrate dm over the ring, we get the mass of the ring, so result will be g m r by r square plus r square whole to the power 3 by 2. This is the result. This is the result. At what point on the axis of ring and the axis of ring gravitational field is 0, gravitational field 0. So suppose this is a ring, the ring, and at a distance r, at what point gravitational field equal to 0? If we gravitational field equal to 0, if we gravitational field not 0, at which point, now at the question is at what point on the r, what is the graph? Graph will be like this way, this way. So here maximum value, here r equal to r by root 2, maximum value of electric maximum value of gravitational field is at here, which is the value of 2 gm by 3 root 3 r square. This is the graph of gravitational field on the axis of the ring, on the axis of the ring. Now next term, so next term is gravitational potential. Next another important term is gravitational potential. Gravitational potential is denoted by u. Gravitational potential is denoted by u. What is gravitational potential? Suppose here a mass is present, now a gravitational field is produced, now a gravitational field is produced. So what is the gravitational potential at a distance r from this mass? Gravitational potential is defined as a unit mass, work done by the gravitational field in bringing the unit mass from this to this, so from infinity to this point, work done by the gravitational field on unit mass from infinity to this point is called gravitational potential. So this is work done by the gravitational field, work done by the gravitational field from of unit mass from infinity to the point r, at a distance. So what u equal to actually infinity to r. Now what is the, suppose if we take at a distance x, what is the force along force is along in this direction, and what is the work done to move the distance dx towards the m? Work done becomes fx into dx into cos 0 degree. Here fx, direction of fx and dx is same direction, force and movement, because we consider here work done by the gravitational field. Work is obtained, here work is obtained, here gravitational field works on the unit mass. So force equal to, what is force equal to g m into 1 by x square dx cos 0 1 infinity to r, that is gm. Now dx by x square integration is x to the power minus 2 dx will be x to the power minus 1 by minus 1, so minus 1, that is 1 by x from infinity to r. Now if we put this, then 1 by x means 1 by r minus 1 by infinity 1 by infinity. So 1 by infinity equal to 0. We know 1 by infinity equal to 0. Then we get the result u equal to gravitational potential minus gm by r, minus gm by r. Student can memorize this formula, but derivation, here derivation is important because the students, generally students memorize this formula minus gm by r, but actually it is not minus gm by r. If we consider that gm by infinity, that is gravitational potential at infinity is 0, then the result comes. But if we consider that there is a value of gravitational potential at infinity, that is at long distance, then this formula becomes different. Now what is the value, actual formula of ur? Ur will be, if we consider that gm by infinity is a value k, if certain value not equal to 0, a certain value, then the result comes u r will be minus gm r plus a value. So this is the actual result. Actual result is this. Actual result is this minus gm by r plus k. K is the gravitational potential at infinity. Generally we take k equal to 0, so the value is minus gm by r. But when it is not when gravitational potential at infinity is has a value k, then we use this formula u r equal to plus k, where k, what is k? K equal to gravitational potential at infinity, okay, infinity. Potential energy, gravitational potential energy. So suppose this is a mass m and at a distance r a small mass is present. So gravitational potential energy of the system, that is two mass system or three mass system. So here gravitational potential energy of each of this mass system equal to, formula is minus g m by r. So this is the gravitational potential energy of this mass, also this mass, that is we call the system of mass. Potential energy of the system of mass equal to this. Now if there are three mass, suppose here is a mass m1, suppose here is a mass m1, here is a mass m2, here is a mass m3 present, r1, r2, r3. Suppose distance between every mass, distance of these two mass is r1, distance of this mass is r2, and this is r3. Then what is the gravitational potential energy? Minus gm. Then gravitational potential will be u equal to minus g m1 m2 by r1 minus g m1 m3 by r2 minus g m2 m3 by r3. So this is the answer. That is product of every mass by distance, product of every mass by their distance. So this is the result for three system. If suppose four mass is present, here is mass m1, m2, m3, m4 is present. So gravitational potential is equal to minus g m1 m2 by, suppose this is a square of side A. So A minus this mass minus g m2 m3 m4 by A minus this mass system g m3 m4 by A minus this g m1 m3 by A. Four mass system, four pairs we write. Now this pair and this pair, now this pair and this pair. So the result is minus g m1 m4 by distance root over 2 minus. So this is the gravitational potential energy of the 4 mass system. Here 6 pairs, 1 2 3 4, this pair, total 6 pairs. Okay, so if this is a spherical shell of mass and radius r, now gravitational potential at this point u equal to minus g m by r when r greater than capital R. Now at this point, here point is here, now at this point the value will be minus g m by r when r equal to r, and within the cell the value of u will be minus g m by r, so r less than capital R. So this result, so gravitational potential within gravitational potential at any point within the spherical shell will be equal to the gravitational potential at the surface, so value will be same. This is the gravitational potential at the surface, and this is the gravitational potential at any point within the spherical shell, so this value and this value will be same. So graph will be this way. This is the graph. If we gravitational potential versus r for spherical shell, graph will be constant and then varies, then varies. This is constant up to r, and here u proportional to 1 by r, this way, this is up to r. So the graph of the gravitational potential versus r of a spherical shell will be this. A ring, suppose this is a ring and on the axis r, this is m, radius r, so u equal to minus g m by distance, just this distance. What is the distance? Distance is r square plus r square, so r square plus r square, so on the axis. Now on the center, what is the value? On the center r equal to 0, so value will be minus gm by r on center of ring, okay, for ring. This is the graph. Maximum value is minus gm by r, minimum value, then value decreases like this way. This is r, this is u, so for ring the graph will be this. For solid sphere, gravitational potential for solid sphere, if for uniform solid sphere, suppose this is r, so at a distance r, what is the gravitational potential? U equal to minus g m by r when r greater than r, and on the sphere minus gm by r when r equal to r, and within the sphere this result becomes different. Within this point u equal to minus gm to this to r cube 3 r square minus r square. This is the result for when r less than r. This is the result. So within the when the point is within the sphere, this value becomes this, u equal to this. Now at the center of solid sphere, at center, what is the value of u? If we put r equal to 0, the result will be minus 3 gm by 2r. This is the result at center when r equal to 0. At center means when this. Now what is the value of, what is the graph of this? U versus r will be this way. First parabola curve, first inverted parabola, and then this. Minus 3 gm by 2 are minimum value, then the value becomes, value of this increases.